Dear students, I welcome you in this lecture from the topic Linear Programming Problems. In this lecture, we are going to solve some examples on minimization type of linear programming problems. So let us see these examples. First example which we are going to see is minimize z is equal to 5x plus 20y. Minimize z is equal to 5x plus 10y. Subject to 2x plus 3y is greater equal to 18, 3x plus 3y is greater equal to 21, and we have non-negativity constraints, x is greater equal to 0 and y is greater equal to 0. Any linear programming problem has three parts. So first part is objective function. Here, which is the objective function? Z is equal to 5x plus 10y is objective function. You understand that z is equal to 5x plus 10y is objective function. The second part that linear programming problem has is linear constraints. It consists of one or more linear inequalities. So it is called linear constraints. Here we have two linear constraints. 2x plus 3y is greater equal to 18 and 3x plus 3y is greater equal to 21. There are non-negativity constraints. We have two non-negativity constraints, x is greater equal to 0 and y is greater equal to 0. So these are called non-negativity constraints, and non-negativity constraints assure that solution of linear programming problem lies in first quadrant. It will never go in second, third or fourth quadrant. Solution will always be in first quadrant. We are going to solve this linear programming problem by geometrical method or graphical method. This method has several steps. So let us go in step-by-step manner. First step is to plot lines. First step is to plot lines. How lines are plotted? That we have seen in very first lecture. I request you to watch the first video in order to understand how lines are plotted. We have seen several examples in the first lecture on plotting lines. Now, which lines are to be plotted? First of all, note that this is objective function. It is not equation of straight line. So we can't plot this as a straight line. Secondly, these are already plotted, which are y and x axis. So they are already plotted. Now, corresponding to linear constraints, we have to plot two lines. So first line which we are going to plot is 2x plus 3y is equal to 18. So what is point on x-axis for this line? Point on x-axis is given by c upon a, that is 18 upon coefficient of 2. So 18 upon 2, which is equal to 9. And point on y-axis is given by c upon b, that is c upon coefficient of y, which is 3. So 18 upon 3, which is equal to 6. Thus we have 2 points, 9 and 6. 9 is point on x-axis and 6 is point on y-axis. We have obtained these 2 points and join these 2 points to get the line 2x plus 3y is equal to 18. So this is how we obtain first line. Now second line we are going to obtain. So second line corresponds to this equation 3x, or this linear constraint 3x plus 3y is equal to 21. For this line, point on x-axis is given by c upon a, that is 21 upon 3, which is 7, and point on y-axis is given by again c upon b, that is 21 upon 3, that is 21 upon coefficient of y, constant upon coefficient of y, again that comes at 7. So we have 2 points here, this one 7 on x-axis, and here also point 7 on y-axis. Join these 2 points and we get another line 3x plus 3y is equal to 21. So this is how we have plotted 2 lines. This completes the first step. Now second step. In second step, we have to determine common feasible region of linear programming problem. So second step is to obtain common feasible region of linear constraints as well as non-negativity constraints. So due to non-negativity constraints, our solution or our common feasible region will always lie in first quadrant only. I'll request you to refer to the lecture where we have seen how to determine feasible region. Basically, line divides in two parts, origin side and non-origin side, and whenever origin satisfy the linear constraint, we shade the origin side, and if linear constraint is not satisfied by the origin, then we shade non-origin side of the line. So let us determine common feasible region of these two linear constraints. 2x plus 3y is greater equal to 18 and 3x plus 3y is greater equal to 21. So let us first see how to determine common feasible region for this. 2x plus 3y is greater equal to 18. So it is greater equal to 18. We are going to check the linear constraint for origin. So origin has coordinates x at 0 and y at 0. So 2 into 0 plus 3 into 0 is greater equal to 18. This gives us 0 is greater equal to 18. Whether this is true or false, this is clearly false because 0 is not greater equal to 18. 18 is greater equal to 0. So this is false. And if we get false, then we shade which side of the line? We shade non-origin side of the line. So let us shade non-origin side of the line. 2x plus 3y is less equal to 18. Which is the non-origin side of the line 2x plus 3y is less equal to 18? It is represented in red color, this line 2x plus 3y. So this is the non-origin side. Why is it non-origin side? Because origin lies in this part here. Origin lies. So this part we are not going to take origin side. We are going to take other part, which is origin side. I am putting ticks here in order that you will understand which part we are shading of this line. Okay, so ticks I am putting it here. Now similarly we will determine feasible region of another constraint. Another constraint is 3x plus 3y is greater equal to 21. Put values of x and y as 0 because we are going to check the linear constraint for origin. So it will give us 3 into 0 plus 3 into 0 is greater equal to 21, 0 plus 0 is greater equal to 21, that is 0 is greater equal to 21. Again this is false. This is not satisfied. This is false. And again we have to shade which side of the line. If it is true, we shade origin side. If it is false, then we shade non-origin side. So let us shade non-origin side of second line, which is represented in green color. So non-origin side will consist of, I am putting cross here so that this becomes a non-origin side of this green line. So note that we are shading green side, non-origin side of green line. It is represented by the equation 3x plus 3y is greater equal to 21. Now what is our problem? Our problem is to determine common feasible region, means where both cross and ticks are there. So we can't consider this region because only cross are there but ticks are not there. Similarly, we can't consider this region because it has only ticks but not cross. So the common feasible region consists of this region where both cross and ticks are there. So this is going to be our common feasible region. This region, as I mentioned, we are not going to take this region and this region, but whatever region which I am shading is this. So in order to clearly understand, let me erase this. Whatever is in white color, that is this shaded portion, is the common feasible region. So second step is over, that we have determined common feasible region. Now third step is to identify vertices of common feasible region. Vertices of common feasible region. Which are vertices of common feasible region that we are going to determine. Okay. So here you can see we are going to have three vertices. Say I'll call this as point A, this I'll call as point B, and this I will call as point C. So we have to determine coordinates of points A, B, C. We have already determined points C and B while plotting lines. So C has coordinates 0, 7 and point B has coordinates 9, 0. Here you can see C has clearly the coordinates 0, 7. Note that any point on y-axis has its x coordinate at 0 and any point on x-axis has its y coordinate at 0. So this was point 9, here it is 9 and here it is 7. So we have points B and C. Now the question is how to determine coordinates of point A. So that is the question. Recall that we have seen how to determine intersection point of two lines. So we have used some formula to find intersection point of two lines. Here, what are the equations of line? 2x plus 3y is equal to 18 and 3x plus 2y is equal to 21. These are two equations of line and we have to determine their intersection point. So let us see how could we find intersection point of these two lines. In case you are not getting this, I'll request you to watch the second lecture where we have seen how to determine intersection point of two lines. Here we have two lines, as I already mentioned. 2x plus 3y is equal to 18 and 3x plus 3y is equal to 21. This line is represented in red color and 3x plus 3y is equal to 21 is represented in blue color. What are values of coefficients of x and y? 2 and 3 for first equation, and constant is 18. For second equation, values are 3, 3 and 21. As such, value of a1 is 2, value of b1 is 3, value of c1 is 18, corresponding to this equation. And corresponding to equation 3x plus 3y is equal to 21, we have values of a2, b2, c2 as 3, 3 and 21. So value of a2 is 3, value of b2 is 3 and value of c2 is 21. The formula to determine value of x is this: c1b2 minus c2b1 upon a1b2 minus a2b1, and formula to determine value of y is this: a1c2 minus a2c1 upon a1b2 minus a2b1. You simply have to substitute these values of a1 b1 c1 and a2 b2 c2 and find values of x and y. I request you to pause the video, substitute values of a1 b1 c1 and a2 b2 c2 in this formula and verify that you get x as 3 and y as 4. So intersection point will have coordinates 3 and 4. X is equal to 3 and y is equal to 4. This is how we can determine the intersection point of two lines. Let us come back to the linear programming problem. The remaining vertex has coordinates 3, 4 as we have seen. A has coordinates 3, 4 and the remaining say C and B have coordinates 0, 7. So B has coordinates 0, 7, A has coordinates 3, 4 and C has coordinates 9, 0. This is the third step. Now fourth step is, it is the last step. In this step you have to identify values or you have to determine values of objective function, values of objective function, values of objective function at vertices of common feasible region, at vertices of common feasible region. So feasible region or common feasible region we have determined the objective function. Recall what is objective function. It is z is equal to 5x plus 10y. So here objective function is 5x plus 10y and at three vertices A, C and B we are going to determine values of objective function. So at vertex A, z is equal to, put x as 3 and y as 4 in this. So 5 into 3 plus 10 into 4, that is 15 plus 40 and that equals to 55. Next point is 9, 0. Again substitute x is equal to 9 and y is equal to 0. So 5 into 9, 45. 10 into 0, 0. So we get 45. The last point is 0, 7. Substitute x is equal to 0 and y is equal to 7 here. So 5 into 0, 0. 10 into 7, that is 70. So we get 70. What was the problem? The problem was to identify minimum value of objective function satisfying all these linear constraints. So out of these four values 55, 45 and 70, which is the minimum one? The minimum value is 45. So the final answer is that objective function objective function has minimum value. What is the minimum value? 45. Objective function has minimum value. Which objective function? Z is equal to 5x plus 10y. This objective function has minimum value 45. At which point? It has minimum value at point 90. At 90. So final answer is objective function has minimum value 45 at point 90. This completes the solution of linear programming problem. I request you to solve some more examples on minimization type of linear programming problems on your own. Thank you.